Before I talk about today's lesson, I want to talk a little about some nomenclature with regards to how you can show a multiplication, between a digit and a variable. So a number and a letter. So far, we've done it like this. If we were multiplying a number and a letter, which you'll do a lot of in algebra, we've been doing this, 2 times m. Very straightforward. Well, I want to introduce you to a couple other ways of doing it because you're going to see it this way, and I don't want anyone to get confused. This is another way of showing 2 times m. If you have a letter and a number next to each other, that means that you're multiplying those two together. That is shorthand for that. In fact, this is what is mainly used in algebra, not this. This is very compact. It's takes up less room. And there's another really big reason why we use this. Now imagine your variable, instead of being m, was x. So 2x, and then we're going to multiply them. So now you have 2xx. That's a little confusing. That's a little bit ambiguous. So they decided, well, we're going to allow you to also just do this. 2x means 2 times x. And this is generally what you see. A number and a letter next to each other means multiplication. And there's actually examples of this on the homework. So it's good to get used to it as soon as possible because you're going to see that much more than this. And here's another way of doing it. This is kind of like a shorthand version of this. They wanted to get rid of the x. So they said that 2 dot m, 2 with a dot in between, is equal to 2 times m. So this dot can be a multiplication symbol. That is something you actually do see a lot in algebra as well. Now keep in mind, this is not a decimal. This is not 2.m. This is 2 times m. Okay? So we're going to talk about multiplication and division equations. We're going to draw some pictures and make them into equations and then solve the equations. Katrina buys a package of trading cards. She divides the cards into 4 equal piles. Each pile contains 12 cards. The equation that describes this number of cards in the package is C divided by 4 equals 12. Well, that's nice. They gave it to us. How many cards were in the package when Katrina bought it? Okay, so this is what that model looks like. We have this big package of trading cards. She divides the cards into 4 equal piles. That's 1, 2, 3, 4. Each pile contains 12 cards. So she divided them up. When she divided them up into those 4 piles, she ended up having 12 in each pile. Okay, and the equation that describes this is C divided by 4 equals 12. C divided by 4 equals 12. Well, if you're not sure how to solve this, C, by the way, is the total number of cards she had to begin with, and that's why it's bracketing the entire box. Now, C divided by 4 equals 12. You might not know how to do this, so let's look at this picture and rewrite it as a multiplication equation. Well, if I look at this, I know that everything in this box is equal to C because C is everything in the box. So if I look at this box, I have four boxes, smaller boxes, and each one has 12. So that's 4 times 12, and that is equal to C. These two equations are equivalent, just different ways of expressing it. But if you look at it this way, you'll see that to solve a problem like this, C divided by 4 equals 2. We need to figure out what big number we divide by 4 to get, 12. You need to figure out what big number we need to divide by 4 to get 12. You could think about it that way, or you could think about it this way. Well, that big number is just going to be 4 times 12. Well, I have a division problem here, and to solve it, I did the opposite of division. To solve what's here, I did the opposite of division. I said 12 times 4 equals C. And C is, and whatever this is going to be my answer. So 4 times 12 is 48. So now I'm going to check and see if that works here. So I just replaced C with 48. Then I just calculated 48 divided by 4. 4 goes in 1 time, 4 goes in 8 2 times, and I do get 12. 48 divided by 4 is 12, so her original pack of cards had 48 cards in it. Here are a couple more problems. The cost of 3 pencils is 96 cents total. Each pencil costs the same. What's the cost of 1 pencil? So we drew a picture. They drew a picture for us here. This box is all the pencils. If we cut it up into pieces, then to 3 pieces, that represents 1 pencil per box because we have 3 pencils. Okay. Now we know the whole thing is equal to 96 cents, but we don't know what each one is equal to. So I'm going to say, well, I know that 3 times whatever's in this each box equals to this whole thing here, which is 96. I like to express it as 3p equals 96. These two are the same thing, but this is a little bit, it's a little bit more terse. It's cleaner. So this is a multiplication problem. Well, you can also express it in another way. You can say that I start out with 96 and I divide it into 3 pieces. I start with 96, I divide it up into 3 pieces, and each piece is going to be equal to the letter P. Okay, so now I have all my numbers on one side. It's much easier to see how to do it. So how to figure out the answer. So 96 divided by 3. 3 goes into 9 3 times, 3 goes into 6 2 times. So I get 32. Now, notice that this problem has multiplication in it. You're multiplying a digit and a variable, a number and a letter. But to solve it, you have to go backwards. You have to take this big number here, 96, divided by 3, and then you get your variable. Okay, and when we made this equation here, that became very clear that that's how you do it. And I got this equation by just looking at this picture and making sure all the numbers were on one side. So again, if you have an equation where you're multiplying a digit and a letter, you will solve it with division by doing backwards multiplication, which is division. Okay, well, let's look at this one. A gardener is planting 6 rows of spring bulbs. 1, 2, 3, 4, 5, 6. Each row has 15 bulbs. We can see they wrote that in for us. How many bulbs is he planting? Total. So we don't know the total. Let B equal the total number of bulbs. Okay. So I can look at it this way. I have B, and if I divide it up into 6 rows, I will get 15 bulbs per row. Another way I can think about it is I can just say, well, there's 6 rows, 15 in each row, so I multiply that, and that's B. Okay? So once again, I'm illustrating that if you have a division problem with a letter and a number being divided, the way you would solve it is to go backwards by multiplying. 15 times 6 equals B. This one this equation is something I got just from looking at this. There's 6 of these squares, and I multiply it by 15, and I get B as my answer. Now this is an illustration of why multiplying these two numbers is how you would solve a problem like this that has the division of a letter and a number. Okay, so let's do that. 15 times 6. So we end up with 90 bulbs. Here are some examples that don't have pictures. Okay, we're going to take what we learned from here. When you multiply a letter and a number in an equation, you solve it by doing the opposite, dividing. When you divide a letter and a number in an equation, you solve it by doing the opposite, multiplying. We can take those principles and apply them here. So I'm taking 128 equals 8 times d. Well, I can solve that since I'm multiplying a letter and a number. I can solve it with division. So 128 divided by 8. 8 goes into 12 one time, and I get 16. So it looks like d equals 16, but I'm going to check my work. I'm going to replace d with 16. So this becomes 128 equals 8 times 16. Well, does 8 times 16 equal 128? Let's check that. 6 times 8 is 48. 8 times 1 is 8 plus 4 is 12. It does equal 128, so D does equal 16. Okay, now we have R divided by 9 equals 17. We know if we're dividing a letter and a number in an equation, we solve it by multiplying the numbers in the equation. So I multiply 17 times 9, and I get 153. And if I want to make sure that that's the right answer, I take that and I replace R with this number and just calculate this equation. So 153 divided by 9. Let's see if we get 17. 9 goes into 15 one time, and I get 6. Bring down the 3. 9 goes into 63 7 times exactly. So I get 17. So 153. R does equal 153. So that's my correct answer. Now I have 6m equals 78. Well, remember, a letter and a number next to each other means multiplication. So this is 6 times m equals 78. So since there's a letter and a number being multiplied, that to solve it, I have to divide the two numbers. So 78 divided by 6. 6 goes into 7 one time. And I break down the 8. 6 goes into 18 3 times. So I have m equals 13. So let's check that. 6 times 13 should equal 78. Let me double check that. Yes, it does. So m does equal 13. And now we have 7 equals b divided by 17. Since we have a division problem with a letter being divided by a number, to solve it, we multiply the two numbers. So 17 times 7 I get 119. So let's check that. I'm going to replace b with 119. So if I divide 119 by 17, I should get 7. So I'm going to guess and check. Well, 17 goes into 1 0 times. It goes into 11 0 times. So I need to figure out how many times 7 goes into 100, or 17 goes into 119. So 80 is too small. So let's try 6. 102. That's pretty close. Let's try 7. $119. So that's perfect. So it does work. So B equals 119.